Hello and welcome back to Zig's Math Lessons. Today, a lesson that covers some details about the limits of functions. The limit of a function is the y value that a function approaches as x approaches a certain x value. More formally, the notation, the limit of f of x as x approaches a is L, is read, the limit of f of x as x approaches a is L. It means that the y value approaches the value L as x approaches an x value of a from either side, left or right. Here's an example of a function. A parabola opens down with the given equation, negative x squared minus x plus 4. And let's consider the limit as x approaches 1. As x approaches 1 from the left, this is what the notation here says, as x is approaching 1, and the little minus sign means from the left. And we can see that as we approach from the left an x value of 1, the y value it is approaching is 2. Next, let's consider what happens when we can approach this x value from the right. So from the right means go to the right and then get on the blue line and then approach an x value of 1 along the blue line, the function. And here's the notation, as x approaches 1 from the right. And we can see that, yes, as x approaches 1 from the right, the y value that the function is approaching is the number 2. From the graph, we see that as x approaches 1 from the left or from the right, the limit is 2. So we say the limit as x approaches 1 of f of x equals 2. One-sided limits, formalizing what we just said. Left-hand limit is x approaches a from the left. The limit of f of x equals L, approaching a from the left. And the right-hand one, the limit as x approaches a from the right. These are one-sided limits, a left-hand limit and a right-hand limit. I made one L and I made one M because these one-sided limits are not always approaching the same number. Two-sided limits, as x approaches a from the left, it's L, and as x approaches from the right, it's also L. And if that's true, then we can say that the limit as x approaches a without the proviso left or right of f of x exists and is equal to L. This limit as x approaches a is called a two-sided limit. Let's evaluate some. Consider the blue line, a function of x. The limit as x approaches 1 from the left of this function is 3. Let's approach from the left. So along the blue line from the left of the number 1, because x is approaching 1 from the left. There's 1. Approach it from the left here. We see that the y value is approaching 3. From the right, if we approach 1 from the right, so we have to approach an x value of 1 from the right, we see that the y value is 3. Because these are equal, we can make this statement. The limit of f of x as x approaches 1 is 3. Let's do this next one. The limit as x approaches 1 from the left. So we have to go to the left of an x value of 1 and approach along the function, and we come to a y value here of 1. And that's what this is. Let's approach from the right. As x approaches 1 from the right, so we have to approach an x value of 1 from the right, so we have to go to the function and approach an x value of 1 from the right. We come to a y value of 4. These aren't equal, so we have to say this. The limit as x approaches 1 does not exist. The two-sided limit doesn't exist. And now finally, let's approach 1 from the left. The limit as x approaches 1 from the left of f of x is negative infinity. Now I take issue with math people who call this negative infinity, but I typed it up here anyways, because some math people do say that. Other math people say that it decreases without bound. It's limitless. Infinity is not a number, it's limitless. So really, the limit, in my view, doesn't exist. But some say, no, the limit is negative infinity. And when we approach from the right, approaching 1 from the right, we have to go to the right of an x value of 1 and approach. And we see that we are reaching for positive infinity. And so for a couple of reasons, the limit as x approaches 1 does not exist. First of all, it's decreasing without bound, so there's no bound, so there's no limit. It's limitless. It's increasing without bound. Again, there's no number, so it's limitless. So for that reason, and for the reason that these two aren't the same, the limit as x approaches 1 does not exist. Let's try one using algebra, using a table to find the limit of a function. There's a function. Let's find the limit as x approaches 3 of this function using a table. So we'll approach from both sides. Let's start by approaching from the left. As x approaches 3 from the left, that's what that means. So to the left of 3, we find the number 2. And then approaching 3, 2.5, 2.9, 2.99, approaching 3. Taking these numbers and subbing them in here and doing the math, mentally if possible, on a calculator if necessary. We get these numbers, and they seem to be approaching the number 7. Let's consider approaching 3 now, the x value of 3 from the other side, from the right side. Now to the right of 3, we have the number 4. And then approaching 3 from 4, we have 4, 3.5, 3.1, 3.01, approaching the number 3. Taking these values and plugging them into the function, we get these numbers. Check them. Check some of them for yourself. Don't take my word for it. And we see that, yes, as x approaches 3 from the right, it looks like the function is approaching 7. As x approaches 3 from the left, it looks like the function is approaching 7. And so we can make the statement. As x approaches 3 from the left or the right, we see that the limits are equal, so we can say the limit as x approaches 3, with no proviso, of f of x equals 7. I'm not Ziegelby at Beachdunk, but thanks for watching. If you liked it, leave a like. If you like the content, please subscribe. And asking questions in the comment section might be productive.